How are we doing, people? Mr. Schreiber is back at it again, and we are going to be going through our final units of the entire year, which is going to be probability, which is also one of my favorites. So we're going to get right into it, and we're going to start by looking at theoretical probability versus experimental probability. Two different things. You may have heard of this before, but they can be a little tricky when it comes to answering problems. So the probability is basically the chance of something happening. So the chance of, for instance, you win the lottery is a probability. The chance of when you get a starburst and you want the next one to be pink, because pink, in my opinion, is like the best flavor ever, there's a probability that it will happen, because if it's 1 out of 5, then the probability, the theoretical probability, would be 1 out of 5. It'd be 20%. So, for instance, what's the theoretical probability of flipping heads? You probably know it's 1 out of 2, or 50%. Or we can even write that as 0.5. And we write that because it is the number of favorable outcomes divided by the total possible outcomes. So, for example, there's only 1 heads and there's 2 options. Well, the experimental probability is a little bit different. The experimental probability means that we actually have to do the experiment. We actually have to flip a coin so many times to figure out, is it really 50%? You say, well, that's crazy. It always is going to be 50%. And the answer is no, it's not. Let's see if we take a look here. Let's say we have heads, which is going to be 14, and tails, which is 16. And my question for you would be, what is the theoretical probability of that? That's not 50%. It is the number of times you got heads, so the number of times that the event that you wanted occurred, and then the bottom is the one that changes. It's the total number of flips, or the total number of times you did the experiment. Well, guys, it's not 14 over 16. It's not 14 over 16 because we have to add these together for the total number of times that we did this. And you can see that the theoretical is different than the experimental probability. And we're always going to put this in simplest form. Very important, you always put this in simplest form. And it is 17 over 15, which again is perfectly fine. But if you guys remember from your lesson from earlier this week, 7 divided by 15 gives you this decimal. Gives you this decimal right here. 6 repeating. And we're going to round that to 47%. We're going to say that 47% chance of getting heads. So that's experimental versus theoretical. In theory, we should get 50%, but it doesn't always work that way. Let's take a look at another one. I bet you guys could tell me, what is the theoretical probability of getting green? I bet all of you guys could. What's the probability of getting green right here? If each of these sides is equal, if I spun that right there, I know that my theoretical probability of getting green is 1. There's 1 out of a total of 4. Or we could say that's 25%, or we could say it's 0.25. And you guys could say, okay, that's the theoretical. In theory, we should get 1 out of 4. But if we do the experiment, maybe we don't get that. Maybe we get something different. I mean, couldn't you get like 10 greens in a row? You could. It's not really likely to happen, but it could happen. So how do I find the theoretical probability of this graph? And by the way, this is basically your first question of the unit. It's going to have a problem like this. It should be 1/4. It should absolutely be 1/4. But in this case, take a look. We have 3 times that it hit green, 2 times it hit purple, and we have 7 times, wow, that's pretty crazy, 7 times it hit orange, and 2 times it hit black. So my question to you is, what is the experimental probability? Take a look up here. What is the experimental probability? Well, it should be, if we're trying to find the number of green, it is 3 out of how many? 3 out of, well, let's add all these up. Let's add all of the times that you did it. How many times did we spin this? And if you want to take a look right now, take a look. I'm going to maybe pause the video, and I want you to tell me, I'm going to get all these lines out of the way. Tell me, how many times did we spin this? Well, 3 plus the 2, I'll make a list. 3 plus the 2 plus the 7 times, heck, it hit orange, and then the 2 times it hit black. Well, we spun this. 3 plus 2 is 5, plus 7 is 12, plus 2 is 14. So the probability, the experimental probability, is 3 out of 14. Not the same as 1 out of 4. Not the same, right? Sometimes it is the same. Sometimes it's exactly the same. But oftentimes it's not, because in real life, things don't happen exactly how you'd like. So here we should get 25%. It should be, in theory, we should get 25%. But if you divide this, guys, you get this decimal. We're going to say 21, and we're going to put 4, and then we're going to change that to 21.4% probability. Okay, and we can do this with any single one. We can find the purple. Purple would be 2 out of 14. Orange would be 7 out of 14, and black would be 2 out of 14. And that's basically how you find the experimental. All right, last but not least, we have this number cube right here, or we can call them dice. And if I said, what's the probability if I spin this, what's the probability that I'm going to get a 3? Well, you should know that when you roll a dice or roll a number cube, we're supposed to say number cube, there are 6 possible outcomes. 1, 2, 3, 4, 5, 6. And there's only one 3, right? There's only one 3. So the probability of rolling a 3 is 1 out of 6, which, if we divide that, we can take 1 divided by 6, 1 divided by 6, and we're going to get 0.16 repeating, and we're going to round that to 16.7%, because that goes on forever. Well, in theory, we should get a 3 16.7% of the time, in theory. But that's not always the case, right? When you roll the dice, maybe you get a bunch of 3s in a row. So the experimental probability, I have 1 up here for you. Can you tell me right now, take a look right here, what is the experimental probability here? Take your time. What's the experimental probability of getting a 3? And if you take a look here, it should be 2 out of 6. 2 out of 6 is 1/3. Well, let's just, you know what? This is live right now. We're going to try this right now. I'm going to spin every single one of these, and we're going to do the experiment right here. Let's do the experiment. What is the theoretical probability of rolling a 3? Well, we got lucky, didn't we? We start with, how many 3s do you see? We see 1, 2, 3. There's 3 3s. And then how many? This is the key. This is the most important part. The most important thing you have to remember today is that when we do the experiment, it's the total number of times that you do the experiment. And how many times did we spin this dice? Not spin. How many times did we roll the dice? And you should put 6. The probability here is 1/2, or 50%, or 0.5. Okay, very cool. So guys, that's a very basic outline. Here's what I want you guys to know. There is a relationship between theoretical and experimental. We actually did this. We did this early on in the year, and I want you right now, if you're watching this at home, and it should be everyone in my core 2 and 3, I want you to pick a color. I want you to pick a color. And I'm going to tell you right now, we're going to spin this thing, and we're going to spin it 10 times. And it should be, in theory, your probability of winning is 20%. But if you get 22%, I'm going to say that you're a winner. I'm going to say that you're a winner, and you don't have to do any work for the rest of the year. How about that? If you get a 22%, you don't have to do the work for the rest of the year. Are you ready? But the only kicker is this. I get to spin this as many times as I want. Okay? So here we go. Pick a color. You got to have a color in your head. You can say it out loud, real loud, so your parents can hear it. Hopefully you pick blue, because blue is now winning, right? Blue is winning. And right now, currently, you are in the lead, and you don't have to do any work. Well, wait a second. I'm going to roll this 100 more times. I'm going to 100 more times. We're going to spin this 100 more times. And, maybe that blue is not the best call, because now you're at 28%. Watch what's happening here. And you should see this. Over time, if I crank this up to 1,000 spins, and I keep going, watch what happens. The probability, the experiment, gets closer and closer and closer to the theoretical. If you pick blue right off the bat, you were really great. You were really great. But over time, I'm going to change this to 10,000. In fact, I'm going to change this to 100,000. And we're going to spin it, and we're going to spin it again and again and again, and watch what happens. They slowly but surely move towards, like all those numbers are moving towards 20%. All of them are moving closer and closer to to 20%. The numbers are changing, but there is one pattern. The pattern is they're all moving closer and closer to 20%. All right, if we keep doing this, you'll notice over time, all of these are getting really, really close to 20%. And even if they're not perfect, it's really close. And so the rule that I want you to remember is if you increase the number of trials, if you do an experiment again and again and again, then your experimental probability will move you closer to the theoretical probability. And that's how casinos make money, guys. The casino always has like a better average than you, and they always want you to play as much as possible because they know over time you're going to be, they're going to win every time because they have a better advantage than you. Okay. Guys, we're going to take on a couple problems. These are the problems you're going to see very similar on your checkout. It says Duke, this guy's name's Duke, has a spinner that is divided into 6 equal-sized sections. Each section is a different color. He spun the spinner multiple times, and his results are shown below. Okay, so the question is, based on the data, what is the experimental probability that Duke will spin a red? Well, if you said this, there's 1, 2, 3, 4, 5, 6, and they're all equal. Well, guess what? Here it is right here. If the theoretical, in theory, the answer should be for all of these guys, the answer should be to get a red is 1. There's 1 out of 1, 2, 3, 4, 5, 6. The probability is 1 out of 6. In theory, you should get 1 out of 6. That's the theoretical. We're not asking for the theoretical today, guys. We're asking for the experimental. So the experimental is 4, right? 4 red. But my question is 4 out of how many? And what number goes on bottom? The number that goes on bottom is the total number of spins. Remember that theoretically, we should get 1 out of 6. But when we do the experiment, we got 4 red, we got 11 blue, we got 3 green, we got 7 yellow, we got 2 purple, and that's 10. That is 13 brown. Brown was a really popular choice. If you were gambling, you probably want to choose brown. The question is, I need you guys to add all these up because we need to know the total number of spins. This always goes the total number of spins or whatever you're doing. How many times did you do the experiment? So I'm going to take out my calculator right now. I should have had my calculator. I'm doing something I tell you guys not to do. I'm using my cell phone. You say, bad, Mr. Schreiber, I shouldn't be doing that. And I got 40. So the probability is 4 out of 40, which is equal to, I'm going to write it over here. I'm going to put it down below, 1 out of 10. Or you can say that's 0.1. All these are correct answers, or you can say 10%. That's what it is. But now we know this information. You can solve any of these. What's the experimental probability of getting 11? I'm sorry, blue. Well, blue is 11. 11 out of 40. We can use that same number. It's just we did it 40 times. And so we can take 11 divided by 40. And we get 0.275. And we're going to move that decimal over twice, and we should get 27.5%. And last but not least, I'll put it up here. Purple was the least amount, right? Purple was 2 out of 40. Remember that bottom number is always the number of times that you do it. And I'm going to tell you right now that 1 out of 20 is 5%. 5%. Notice how none of these, not a single one, is actually the theoretical probability. Theoretical is 1 out of 6. None of them were. And that's kind of how life is. The experiment's different than the actual. Let's take a look at another example. And I'm going to tell you guys right now, it's going to look a little confusing. But what I'd like you to do is feel free to pause this and just take a look at this problem and see what it's asking. It's meant to kind of confuse you with the table that it gives you. And I think they do this on purpose because they want to really see, are you paying attention? So let's read it. It says, Eden spun the spinner 12 times and recorded the results in the table below. Okay, so the spin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Really, this is meant to kind of confuse you, but look right here. Look at the results. Look at the results. Okay, you have a 4, a 7, a 1, an 8, a 6, 3, 2, 4, 1, 4, 7, and 10. And I want you to tell me, what is the experimental probability if you were to, just looking at this data, we're just looking at this data right here of getting an 8. Well, I think it helps to kind of write this out. I'm going to get out my trusty highlighter, and I'm going to highlight every time I get an 8. There's 1 there. And guys, that's it. Don't circle this because this stands for this spin. You spun this, 12 times. In fact, it may help, and they do this on purpose, is get rid of this. You don't need this. You don't need to know the number of spins. I just want to know the number that you got when you spun it. When you spun it, what'd you get? I don't need the spins. And they do that on purpose. They do that on purpose to try to confuse you. So guys, what's the experimental probability? Well, how many times did 8 occur? 8 occurred 1 time. The question is, what number goes on bottom? The number that goes on bottom is the number of times that you did the experiment. And if you take a look here, you spun the spinner 12 times. So your experimental probability is 1/12, 1 divided by 12, which is 0.083 repeating. And we're going to say that is 8. We're going to move that decimal over to 8.3%. Not good. Not great. Let's take a look at another one. And I'm a huge fan, guys. If you think you've caught on, that you can try the next 2 on your own. I think that's the best way to learn. Maybe pause it, and then you guys can kind of scrub through it and go to the front just to see if you got your answer right. So the probability experimental of getting a 4, there's 1 there, there's 1 there, and there's 1 there. Well, this answer is going to be 3 out of 12, which is equal to 1/4, which is equal to 25%. Or we can write that as a decimal. I'm going to put this answer right here because my face is blocking. My face is getting in the way. And what's the theoretical probability of getting a 10? If you take a look here, it should be, I believe, the exact same answer. There's only 1 of them, right? So it's going to be the same thing as getting an 8. There's just 1 out of 12 total, and it's going to be 8.3%, or 0.83 repeating. Okay? Why do they do this? They do this to confuse you. These numbers here are just the number of spins, and they kind of put it in a way sometimes like that to confuse you to see if you're really paying attention. Guys, we're going to do one more, just one more example, and let's read it. It said, Fred is going to flip 1 coin 4 times. So you're going to take a coin and you're going to flip it 4 times and record whether it lands on heads or tails for each flip. The list below shows the possible outcomes for each of the 4 flips. So it's important to know that this here stands for 1 outcome because he does it 4 times. So this outcome here would be heads, 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 and heads. And how many times does he do it? How many outcomes are there? Can you count? How many total times does he do this experiment? And here's what I don't want you to do. You're not going to count each individual one because this stands for 1 outcome. That's 1 outcome. That's 1 outcome. And that is 1 outcome. And you should have this key number. This is going to be the most important numbers. How many outcomes were there? And there should be 16. Okay, let's take a look at our questions. I'll put this over here. Okay, what is the probability of getting 2 tails and 2 heads? 2 tails and 2 heads. What I like to do is I'm going to start with this. I know for every single one of these, I'm going to put out of 16 because I know there's 16 total experiments. He did this 16 times. So I'm going to take out my trusty highlighter and we're going to do each one at a time. 2 tails and 2 heads. 2 tails and 2 heads. There's 1. 2 heads, 2 tails. There's 2 tails. There's 2 heads. That's 2. There's 1. There's 1. I should be more methodical. Here we go. No. 2 heads, 2 tails. There's 1. And then I'm going to double check to make sure that all the rest are not. Okay, so how do I find and this is where you have to look at the data. You have to break it down and say that the probability of getting 2 heads and 2 tails, the experiment, just the experiment, is 1, 2, 3, 4, 5, 6. There's 6 out of a total of 16. And again, let's put this in simplest form. 3 over 8. And again, you want to use the lesson from yesterday or early on this week, whenever you decided to watch it, is that when we change this to a percentage, which I like percentages the most, it's going to be 37.5%. Okay, let's try the next one. And we have 2 more, and that's it, guys. 2 more, and we're all done. Let's get my highlighter, and let's do green this time. It says all tails. It's all going to be tails. Nope, 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 nope. Oh man, I don't think I even meant to do this. But is there a probability? The experimental is 0 out of 16. Guys, that stinks because that is a 0%. Didn't happen. Oh, wait a second. What does Mr. Schreiber always say? Double check your work. And what is he not doing right now? And students are yelling at the computer, Mr. Schreiber, you're not doing it right. Maybe I did that on purpose. That's not true. I did not do that on purpose. I see one. Sorry. Double check your work. There's one. Let's double check to make sure I didn't miss another one. This is live, people. I may have to scrub this. I may scrub the whole thing out. And you guys can see there's 1 there. 1 out of a total of how many outcomes are there? There's 16. I remember when I wrote this. I mean, heck, I'm writing the lesson. I should have been able to get it. And the decimal is 0.0625. And that is going to round to 6.3 because you're going to round that up. Percent chance of happening. And last but not least is going to be 3 heads, guys. I'd like you to try this one out on your own if you haven't already. Let's put it in purple this time. 3 heads. There's 1. There's 3 heads. There's 3 heads. And I should put this exactly 3 heads. I'm going to have to change that because could you say this is 3 heads because there's 3 heads or more. In this case, we're going to say exactly 3 heads. And I'm just going to go very carefully because I messed up the last time. I'm going to very carefully double check every single one. Okay, I think we got all of them. And you guys can see that how many? There's 1, 2, 3, 4. There's 4 out of 16, which is equal to 1/4, which is equal to 25%. Or you guys can say it's 0.25. All these answers are right, by the way. You guys could say this, this, or this. I kind of like the percentages the most, but you guys could technically put it any way you want as long as you put the fraction in simplest form. Everybody, that is it. That's what you have to do. Make sure you look back on this video. If you have any more questions, please reach out to me. And I'd love to see more people join the conference. We've had a few people that have tried. I want to give a shout out. Troy Cease came in. Olivia tried to come in. I know we had some technical difficulties, but I know Tyler tried, and I also know Grayson also tried. So I really appreciate it. I'd love to see you this week. So yeah, look out for that. Come say hi. I'd love to talk to you.